Dear students, myself Dr. Zuma Parveen. In our previous lecture, we have started thermodynamics first. Today is our fifth lecture. So, in our last lecture, we have solved the problems based on maximum work done. Today we will Today we'll learn the first law of thermodynamics, internal energy and enthalpy. So, as we have studied earlier, therm means heat and dynamic means power or motion. So what is thermodynamics? Thermodynamics is the study of heat energy and its transformation into different forms of energy. So now laws. So let us learn the first law of thermodynamics, or it is also called as law of conservation of energy. These are according to first law of thermodynamics. Energy is neither created nor formed, but can be converted into different forms. So first law of thermodynamics, there are different statements of first law of thermodynamics. Means we can state it by different statements, but the meaning of all the statements is same, that is energy is conserved. Like in first statement, see here, the first law is usually referred to as the law of conservation of energy. That is, the energy can neither be created nor destroyed, but can convert it from one form to another. That is, here also energy is conserved. Now see here, the total amount of energy of the universe remains constant. Means the total energy of the universe remains constant. The sum of all the energies in an isolated system remains constant. If one form of energy seems to be disappears, energy in the other form of equivalent amount of make it appear. So you can well understand by using this picture. See here, in this conservation of energy, or we can say transformation of energy. Energy transformation, also known as energy conservation, is the process of changing energy from one form to another. That is the transformation of energy. Like when we eat something, it gets converted into chemical. If we eat glucose, then it will break down into its simpler molecules, and we convert chemical energy from food into mechanical energy. So we can move or we can work by using this mechanical energy. So here also chemical energy get converted into mechanical energy. So the sun turns nuclear energy, or you can say solar energy, into light and heat energy. And apart from this, another examples includes an electric fan transforms electrical energy into kinetic energy. Or you can take a home appliance like toaster, in which when you switch it on, um, this electrical energy get converted into thermal energy. Here also, in this case, lightning converts electrical energy into light, heat and sound energy. So in all these examples, one thing is common, that one form of energy get transformed into another form. So here energy neither created nor formed. So take some more examples, like in this picture you can see a boy is hitting the ball on the tree. So what happening? The energy is not destroyed. The energy which is used, the energy which apply here on ball is not destroyed, but transferred to the tree. In this case, you can see here a car is crashed on a wall. So when it crash on a wall, so here kinetic energy of the car is get converted into fire energy. So it is not destroyed, it is just getting converted from one form to another form. Again, that is energy is neither created nor destroyed. So in this case, this is the home appliance or kitchen appliance. that is oven, the electric energy when you switch on, so powering the oven, is being transformed into thermal energy. Or electric heater, water heater is also example of electric energy into thermal energy. Our iron is also example of electrical energy, and electrical energy get converted into thermal energy. So in all these examples, the energy get transformed from one form to another, that is energy neither created nor formed. So this is the first law. So you can state this first law in the modified form, like the sum of mass and energy of an isolated system remains always constant. That is law of mass action. Now we will see the mathematical formulation of first law of thermodynamics. So suppose a gaseous system in which the internal energy of